अस्सलाम वालेकुम, मेरी आवाज़ आ रही है क्लियर? Okay, excellent. Okay, this is lecture number 5, live lecture, which we will be covering, I think, lecture number 13, 14, and 15 of the recorded lectures. I hope you have seen them already, and let's get started. Everyone can also see the screen which says W163 Computers and Programming Live Lecture 5. Okay, I just say 1 or 0. Okay, excellent. चलिए ठीक है, आगे चलते हैं. Some things we need to discuss. Number one thing is the main topic of this lecture number 13, 14, and 15 was actually floating point numbers, IEEE 754, and in which we discussed the type upgradation and typecasting as well. In type upgradation, let's say a smaller type can be fitted into a bigger type. For example, if you declare a variable of type integer, let me write it down first. Let's say if you declare a variable of type integer a equals to 10, obviously it's going to occupy about 4 bytes. But if you declare a variable integer long equals to, for example, b equals to a, now a will be type upgraded to, the value of a would be now assigned to value of to variable b, and now this variable b would be occupying I think about 8 bytes. So this is type upgradation. Another thing I needed to discuss was uh, is this thing over here, which says that if you have a something known as typecasting, that this thing integer bracket a and integer in brackets as well as a will have the same result, but behind the scene they have different behaviors. The result is absolutely the same. So if you are just writing the program, you can use either one of these things. If you want to convert some number into an integer, you can use either integer a like this, or you can use something like integer in brackets and then here. But behind the scene, there is a slight difference because they usually ask these things in some interview questions. So you should know what is going on behind the scenes. So this thing, if you write integer in brackets and then some number, or maybe it's an expression which yields some numeric value, this thing is actually typecasting. So this thing is going to convert whatever is here to an integer and then return that integer or assign it to some other value. Now this thing integer and in brackets of a, this is actually calling a constructor of integer class. Remember, in C++, everything, pretty much everything, is an object. We will be dealing with object oriented programming after midterm, but since this topic has been discussed in the recorded lecture, so you need to understand it, that integer a is calling a constructor. Constructor is a special kind of a function in integer class to make an integer type object with an initializing value of a. So that means integer can have only whole numbers. It will pick the integer part of a if a is 2.7. So here, let me write it down for you. Let's say if I declare variable integer, let's say float a equals to, yeah, whatever. I'm just going to write integer a equals to, I've declared that already, sorry. So let's say integer c equals to, if I write integer 2.7, so that is actually, this line is actually calling the constructor of integer class, making an integer object, and it initializing that integer object with a value of 2, because integer can only have whole numbers. So it will just truncate this thing. It will not round it off to 3. It will just pick the value, the whole number part of 2. And here, this thing is actually making an object, but the end result is same, that if c will contain the value of 2. However, if I write something like this, if I write integer and then I write 2.7, if I write something like this, that means that oh sorry, इसकी screen बड़ी करते हैं. एक मिनट, एक second. I think this is okay. Is it okay, मुदस्सिर? अब सही है? Okay. अच्छा, चलो अच्छा वो बता दिया. Okay. So if I write this thing, this is known as actually typecasting. This is actually typecasting. So in the recorded lecture, I also said that if I write, for example, integer 2.7, I said this is typecasting. This is actually calling the constructor of integer class, but the end result is exactly the same. So you can use either one of them. This thing will make this. This will typecast this 2.7. This will typecast 2.7 will be converted to an integer. Obviously, it's not going to round off to 3. It will pick the value of 2, and then it will assign the value of 2 to variable c. I hope that makes sense. So you can use either one of them, no problem at all, but behind the scene logic is slightly different. Okay, so using that, and I also discussed in the recorded lecture that if both of these variables, sorry, if both of these numbers are integers, the answer would be an integer. But if any one of them is a floating point number, the whole expression would be upgraded to double type floating point number. The default floating point type is double, not float. So it's a double precision floating point. If you want to do long double, that's extended precision. But I've discussed that if you, both of these numbers are integers, then the answer would be an integer. But where can anyone suggest, can anyone tell what would be the output of this code? If I write 24 divided by 7, so it's 7, obviously it's not perfectly divisible by 7. So 7 into 3 is 21. So obviously the output of the first line would be 3. But this thing is also 7. Yes, this is 3. The first line is 3. But what would be the output of this line or this line? The second line or the third line? Because you have to keep in mind that this number I have written, even though that's a perfectly whole number, but I have written it in the format of a floating point number. So it's 7.0 is a floating point number. So that would mean that the whole expression would now be upgraded to double type floating point number. So can anyone guess what would be the value? Would it be 3, or would it contain some, yeah, exactly, Nabil Majid has said exactly right, that it would be 3 point something. It will not be just an integer. So that's important thing to remember, that if any one of the variables, I've explained that in the variable type example, I did not write the numbers in the computer program in the recorded lecture, but here you can see that the output would be 3.42857 in both of these expressions, because if any one of the numbers is a floating point number, the whole expression is actually upgraded to a double type number. When I say double and when I say floating point, I mean exactly the same thing, because type the default type of a C++ program is actually double. If I write floating, that float variable, for example, t, and this called y, for example, this thing, both are things, or even this, if I write long double, yeah, for example, u, for example, so all, sorry, not both, all of these three variables, y, t, and u, are actually floating point numbers. The only difference is the size which they occupy or how much precision they can contain. But when I say in the lecture whether it's floating point or double precision, I mean exactly the same, because by default, if I write an expression, I'm not saying it's the correct expression. If I write 24.0 divided by 7, this whole expression would be upgraded to double floating point. I mean, that's like double precision floating point. So this whole expression, the result of this whole expression would be occupying 8 bytes, not 4 bytes. Reason is because it's no longer, because the default type is actually double. Okay. So, but this to say that we have integers and double C. So EB's answer would be in integer or floating. No, if any one of those and double equals to C, you have written, Mudassir Mahmood has written in the chat window that C equals to A divided by B. So A divided by B is answer would be integer or floating. No, C is type floating. So let's write it down. C is type floating, but here the expression A upon B is actually integer. So let's write it down. Integer A equals to 10, and integer B equals to, for example, 20. Okay, and just write float C equals to A divided by B, and we just remark these lines, all of these lines, actually, all of these lines. Let's run this thing and C out and just C. Okay, so let's run this thing and see what we get. 0. 10 divided by 20. This thing, I was talking about the division. I was talking about the division over here, that this expression here is an integer type expression, because both of these numbers, A and B, is an integer, and the answer would be an integer. I was talking about one of the cases when one of the operands in this fraction is a floating point number. The whole expression would be upgraded to a floating point number. But here the output of this expression only, this expression, the return type of this expression would be an integer, and that would be 0, and that 0 would be assigned to C, and obviously that would be 0.000. Okay, so the double कैसे आएगा, answer float types होगा या नहीं बेटा? Double and floating means exactly the same thing. If I say double type, if I say floating type, it means that they can contain the fractional part. The only difference is that double type floating point number actually occupies 8 bytes, and floating point number occupies I think 4 bytes. Okay, so if I say double or if I say float, as far as our discussion is concerned, it means exactly the same, except the precision is slightly different. Okay, so now moving on to the next part. Oops, sorry, where is that? Okay, so I think we discussed the results. And another thing was we were talking about the uh, composite assignment operators, and they actually add the value. If I write a plus equals to 10, that means it will it will increase the value of a by 10, and then it will update the value of a at the same time. Similarly, if you want to subtract some value from a and then update the value of a, you have to use this assignment operator. If you want to multiply the value of a with something and then update the value, then you use this assignment operator. These are known as composite assignment operator. The last one is the remainder assignment operator. That means if you want to divide a with something and then the remainder has to be assigned to value of a, then you need to use this thing. But only catch or caveat is that this operator, the remainder operator or the remainder assignment operator, can only be used with integers and not with floating points. So you need to remember that this is a common exam question. Another thing we need to remember is that in the next lecture, we will be in the next live lecture probably, we will be discussing the if and else statements. So or I think we will be discussing some problem, but I think the if and else is also in this class as well. This thing is a simple assignment operator. This will just assign the value whatever is written on the right to the left. But here, whenever we are using two equality operators, that so to us equal sign, this is known as an equality operator. So it's extremely important that you do not mix up these two things. This is really important. Single equals to sign means simple assignment. Whatever is on the right is assigned to the left. If you are using double equals to sign, that is actually a logical equality check. For example, let's write a simple code. I mean, it's really common because whenever we are discussing some lecture, we are just discussing that part. But whenever you are taking some exam or something, I mean, you have to keep in mind a lot of things. So it's better if you just keep on practicing, because there are, I mean, the professionals, I mean, there's the difference between an amateur and a professional. The amateurs keep on practicing until they get things right, and then they stop practicing. The professionals, they keep on practicing until they cannot get things wrong. So that is the amount of practice that is required. I mean, this is a very simple error, but if you need to, I mean, I'm just going to declare a variable integer a equals to 10. And if I write, if just a statement is going to check if a equals 10, then I'm going to, sorry, if a equals 10, and I'm going to say C out, okay, that's it. And else, I'm going to discuss extensively this if else statement in the future lecture, so don't worry too much about it. I'm going to say C out, I'm saying not okay. So simple lines. Amy, that means that if a is equal to 10, the returned value would be true or 1. Okay, so that is actually what we are checking, that we have to check whether a is equal to 10. So if we run this code, it's going to check whether a is equal to 10. It's going to say, oh yeah, it's true. So then it will run this line. Had this thing been false, had the value of a would have been like 20 or some other value, so that would have been yielded false or 0. Then this is not true. So it will just print else, and not print else, it will run this line. So that means if I write mistakenly something like, if I write a equals to 20, so obviously this line will not work because 20 is not equal to 10. Obviously this thing is false, but else would be, I mean, if this thing is false, then else would run. I'm saying sorry for in Urdu, but if you, what did I include? Yeah, well, actually it's actually included with this thing. Sorry about it. So अच्छी नहीं लग रही तो उसको mark कर दो. Actually, this thing is actually for the limits of floating point. So I'm going to discuss that in that. So let's say a equals to 20 or 200. So obviously 200 is not equal to 10. So this thing is actually false, and this thing will yield 0 or false. So this thing, if a equals 10, so obviously this thing is false. So this thing is not going to run, but this thing is going to run. So let's run this thing and see what we get. It says not okay because this thing is false. And obviously if this thing is not going to run, obviously else run this thing. So that's how it works. But if I write this thing, if a equals to 10, if a equals to 10, I mean, I should have written if a equals 10, I need to check for the equality of a with 10. But there is a common mistake writing it quickly. If I write this thing, so what would happen? It says okay. So why is that? Actually what happened here is that instead of checking for equality, we assigned the value of 10 to a. So what happened was, since it was a successful assignment and we were assigning a non-zero value to a, the return value or the return, I mean, every operation has some kind of a return thing that if whether it was successful or not, the return type was actually true. Okay, so or 1. Okay, so if I write if a equals to, if I'm going to check if a equals to 0, which it's not, so obviously this thing is not going to run. This thing is actually 200 is not equal to 0. This thing is not going to run, else this thing is going to run. This is okay. So if I write, instead of checking for whether a is equal to 0 or not and checking for equality, I mistakenly did this thing. This is a mistake. This is a mistake that if I mean, I wanted to check whether a is equal to 0 or not, but I did this thing, which is actually a mistake. What I'm doing here is I'm assigning a 0 value to a. So if I'm running this thing, it says you have assigned a 0 value to a, and it returned actually 0 here. So this is kind of a complicated, not complicated, this is kind of a weird looking behavior. Even though that was a successful assignment of 0, but you are assigning a 0 value to some variable, the return value is actually 0. You were assigning a non-zero value to some variable, the return value was non-zero, which is taken as true. So any value other than 0 is taken as true. Any value which is equal to 0 is taken as false. So this thing did not run, and this thing actually ran. So what the point of this whole discussion is that whenever you are using equality operator, or whether you are using the assignment operator, so the common mistake is whenever we are checking the equality of whether some variable is equal to some value or not, so we need to use this equality operator. And whenever we want to assign the value to assign the value to some variable, or assign the value of some expression to some variable, we need to use the assignment operator. So it's important you don't mix these two operators, even though we mean just like writing it once and writing it twice. So it's a very common mistake over here. And these are the composite assignment operators. Only thing to remember is the remainder operator is not used in floating point numbers. Post and pre-increment, I discussed that as well. So the important point to remember is if it's post increment, it's coming up later. If it's pre-increment or pre-decrement, it's coming up earlier. So I mean, the location of the sign is a easy way to remember what will happen. So if I write a plus plus, that will if I a plus plus and is assigned to, if I write, I'm not running this code, I'm just saying that a equals to 10. Let's integer a equals to 10. If I write a plus plus and that's it, I have to go to the next line, it will increment the value a to 11. A is updated to 11. However, if I write integer c equals to a plus plus, so a is now 11 here, because we have crossed the line. We have we have done with this line, we have done whatever is told over here, and now the value of a is 11. Now if I say a plus plus over here, so a value of a was 11, it will be assigned to c will be 11, and then after this line a would be 12 and c would be 11. So reason is because after running this line, the whole code actually was executed. So a plus plus is actually 12 after eventually, but here the value of a assigned first to c and then incremented. If I have written plus plus a, that would have mean that the value of a would have been incremented first, it would be 12 anyway, and the value of C would be 12, and because it was incremented first and then assigned. Similar is the case with the um, if you similar the case with the decrement operator. So Abdullah says if you want to apply more than two conditions, how to use the if else statement. Bhai, ye jo hai, it will be coming up. If you look at the lecture topics, I think this thing is coming up in lecture number 19, 20, 21. Don't remember it right now, but it's written in the lecture topics. So this thing is extensively discussed in lecture number if else lectures, so 19, 20, 21. Not exactly remember where, but it's there. Okay, so you have to use multiple statements. So you have to use the and or logical operators. The short answer is or maybe not operator. I mean, if you want to combine, if this condition is true and this condition is true, or this condition is also true, so you have to use something known as these and operator, or operator, and the not operator. This is a double vertical bar. It's available on the what is that key? The backslash key. You have to press shift over here. So and or not, but this is not a topic of here. But if you want to see, you have to look at the if else topic in your book or in the lecture whenever that is available online. Okay, so coming back to our lecture. Floating point, yeah. Students were asking what is important for midterm and if there are any quizzes. If there is a quiz, I will be announcing it at least 1 week before. There is no quiz right now, but if there is a quiz, I will be announcing it 1 week before the actual quiz. For midterm, you have to look at the lecture topics. I mean, I have uploaded the file of lecture topic is continuously updated whenever I make a new lecture or some lecture is approved by the higher authorities to be published on the website. I just type in the topics there. So keep on, I mean, that file is continuously changing. I'm continuously adding new lectures and the new topics. So the you have to look at those lectures in which I have discussed the problems or the review questions, some practice questions, some practice problems. You have to keep that in mind, as well as some in those lectures in which I have converted binary to decimal and decimal to binary and hexadecimal, as well as the 2's complement format, as well as the IEEE 754 format for floating point number. These are not in the review questions or the problem lectures, but you have to look, you have to practice the conversion of binary to decimal and decimal to binary. If they are whole numbers, if they are negative numbers, you have to use 2's complement, or if they are fractional numbers, then you have to use the IEEE 754 format. So you have to practice that method. Obviously, that is available on the recorded lectures. मतलब जैसे मैं मुझसे set precision explain कर दें. Sir, set precision जो है, that's sorry, set precision means how many digits you want to display. That's it. If I say set precision 10, it will display 10 digits, including the whole number part as well as the fractional part. If I say set precision to 2, I've explained that in I think lecture number 15, maybe, I don't remember. See the very first part over there. If I say set precision equals to 2, it will just try to display just 2 numbers, and the remaining part would be displayed in the e to the power or the 10 to the power format. So it has kind of a mixed behavior. It's not that predictable. Okay, range of floating point numbers. If you're using 4-byte number, this goes to -38 to +38, because floating point numbers can store very small to very large values. Double floating point means it's 8-byte number and has a larger part for the exponent part as well, and larger for the decimal fractional part as well. So it will go from -308 to +08. I could not find the maximum range of long double. You might want to Google it. The reason I included the float.h was file it contained these numbers if you have the correct version of float.header file. So long double I simply could not find. Obviously this long double obviously can have more precision and more the exponent part as well, but what I discovered was that this thing is actually occupying 10 bytes and not 16 bytes, even though I used the size of operator and it was displaying 16. The way the memories are allocated in the computer has to do something with the powers of 2. So either you could have 1 byte or 2 byte or 4 bytes or 8 bytes or 16 bytes. So even though if you might be occupying 10 bytes of memory, because it's an 80 bits number, long double, it is just allocated 16 bytes. So that's actually 6 bytes wasted. That's my theory. It might be possible that there is some implementation of long double which might be using some 16 bytes. So that's one way to go. But my understanding is long double uses the extended precision, or the double extended precision uses just 10 bytes. So that's the case. I mean, the important thing for engineers is to remember that computers do not have infinite precision. That's the thing to remember. So going to quickly here, I discussed this problem in the recorded lecture where I divided 1000 by 3. So x is 333.33. I subtracted 333, so it will contain just 0.333. So if I multiply 3 into 0.333, that should be 0.999. However, had it been a infinite expression, infinite 0.333, that would have been 1. So if I subtracted 1 from here, it should have been 0, but it was not. So that was actually a finite precision error. So that's a very simple problem. So it was like, it's almost equals to 0. So I explained that if z equals to 0, that's where I use that. If z equals to 0, I'm not assigning the value of z to 0. I'm actually checking whether z is equal to 0. So this thing, I mean, it's not a good idea to check for equality in floating point numbers, because if you're expecting some really low numbers, so either you can just convert it into integer if it's a really small number and then check for equality. Otherwise, and not a bright idea to check for equality, because it will say it's not equal to 0, not exactly equal to 0. Okay, so I don't expect you to read this code. This is quadratic equation solver, really simple. Minus b plus minus b square minus 4ac under root over 2a. This is very simple code. This is just backslash t is using for the tab characters if you want to use it or not. The important thing we need to discuss is very quickly that if you write numbers which are 2, 1, minus 3, and you are storing the numbers in floating point, the answer, I mean, the roots of the equation checked out. If you put the roots of the equation in the original equation in place of x1 or x2, the answer should be 0. So that is okay. I mean, the roots are correct. However, if you are going for very large or very small values, the roots of the equation simply do not check out. This is actually finite due to finite precision, because computers simply do not have the infinite memory to store the infinite precision required to store these things. Reason is that even like an fraction number of 0.2 in decimal means an infinite expression in binary, because binary numbers in fractional part go from 0.5, and then the next number is that's 2 to the power minus 1. Then the next number is, after the decimal point, is 2 to the power minus 2, which is 0.25, then 0.125, then 0.0625, and so on and so forth. So I mean, it's not possible to represent a decimal fraction exactly in binary all of the time. So there you have this finite precision, which I've discussed extensively in the lecture. So here it is saying that, I mean, if you want to avoid these things, so you should use, instead of float, you should use double or long double. So that would just minimize the error, but there is absolutely no guarantee that the errors would be eliminated. Here it says enter the coefficient 0 to 5. It says the solutions are not a number means complex, and x2 means minus infinity. So obviously there is some divide by 0 problem over here. Not so sure what that is. You might want to do it yourself. Here, if I write x square plus 1 equals to 0, x square plus 1, obviously x square equals to minus 1, x equals to plus minus iota, or plus minus j in electrical engineering. So this says not a number, so it's complex. So there is a way to, if I write 1, 2, 3, it says not a number. Obviously, it's putting out complex numbers over here. So there is a way to deal with complex numbers. So it's really simple. I will upload the file here. Let me show the file where the complex numbers. Wait a minute. It should be complex here. So I've uploaded the file. I'm going to upload the file, obviously. So it's a handout from some website. I did not write this file. So if you want to declare some variable, you need to write, first you need to include the complex header file, because the real and imaginary parts, I mean, they behave differently. I mean, they have, if you multiply under root minus 1 to under root minus 1, I into I is actually minus. So if you're multiplying imaginary numbers, and they both have the imaginary part in negative, so obviously that would result in a real part and then some other imaginary parts. So they have some different variables. So if you want to declare the complex variables, you have to use complex float variable name. complex double or complex long double. If you want to assign some value, so there is a slightly different. So either if you have declared the variable, you write complex double, and then in brackets you write the real and imaginary part. If you just write the variable equals to this thing, it will just be assigning to real part only. I'm going to demonstrate it in a moment. If you want to declare as well as assign the value, so you have to use complex float or complex double here, as well as complex float or complex double here with the brackets. So let me demonstrate that very quickly, how to do that. Complex number example. So here I've said that enter values of complex number C in this format. I've declared a complex variable of type double, and obviously it will contain the fractional part as well. So contain values of C in this format. So if I run this code, uh, and sorry, let me recompile that. It should be in the brackets. Um, Let me run that again. In this format. So if I open the bracket and I say 2, comma 3, so it will say, I mean, 2 is the real part and 3 is the imaginary part. So I need to put in the brackets and comma as well as this thing. So that's how you deal with complex numbers. And coming back to, sorry, coming back to here, if I run this code, let me explain that. What I've done over here, this is the quadratic equation solver which which you were discussing. Here, what I've done here, since we have not done the if and else extensively, so I have the first part is same. I've taken the values, and then what I've done here is that if discriminant, that is b square minus 4ac is less than 0, obviously square root would be a complex number. So I have taken the square root as a positive number. Real part is minus b over 2a. Then I have imaginary part is square root of that. I mean, it's positive over here. Then what I've done here is, this is important. I have declared a variable complex float. And then I write complex float again, and the real part from here goes to here, and the imaginary part goes from here to here, as well as the x2 is just with minus imaginary. So if I run this code, I simply do not have time to run this code. So if I run this code, it will be I mean 1 2 3 or 1 0 1, it will be displaying the right values in complex format. So here in this code, I'm not expecting you to understand it here, but in this code, what I've done here is that if discriminant is less than 0, I need to declare the complex variables, and then I'm going to assign the real and imaginary parts separately, and then the computations are pretty much the same as you do in real numbers. So else, if the discriminant is equal to 0 or more than 0, so I mean, we do not need to use the complex library. I mean, complex variable, we just have to deal with real numbers. So I mean, if this if is true, so the whole code block is going to run, because I was included that into a curly brackets. Either if this if is false, then this whole code block is going to be uh, false. So sorry, if this sorry, let me repeat that. If this statement is a condition is true, this thing is going to run. If this condition is false, then the else block is going to run. So here is we are dealing with real numbers. Here, if we have to deal with, we are dealing with complex numbers. So I mean, we probably would be dealing with complex numbers later on, but here, since we got the problem of not a number here, so I had to include the complex part as well. So you might want to see the complex.pdf, and if you include the complex file, complex header file, the CMath file is, I think, also included by default. Actually, we are out of time actually right now, so let me check the attendance here. I hope everyone's present. Yeah, Mustini Aya. How to bring hand concern? No, I could not find it. Sorry, yeah, I simply could not find it. Whether it's let me check here. And acha, because hang up. Please do not hang up. I need to take the attendance. So do not hang up. I need to take the attendance. It should be 114. So let me see that. Okay, so 114, I am the 115th, right? So okay, all present. Some okay. So let me save the file. Okay, file has been saved. We have got 2 or 3 more minutes to be on that, so you probably need to join some different class. So actually, in this problem, it is from I discussed in the. I did not upload the book. If you want to, I will upload this book as well. I will upload this book. It's some kind of a banking scam which was offered to some customer. Obviously, it's a hypothetical situation in which we say that if you deposit this much amount, we will take $1, and then so on and so forth. So that gentleman actually wrote the program, but he was using the double precision floating point, and if you are using the double precision floating point, it's actually a loop which keeps on running this thing for 25 times. So I've not discussed that, so I'm not going to the code. But the point is, it's running the code here with the double precision floating point. So due to the precision finite precision, it got he got this value. If I mean I use this code, and instead of writing double, I wrote actually float here, I got this value. So that means due to some compounding interest, he would have this many dollars in his account. But actually this is not possible because the bank was actually using the exact mathematics, and the bank was not using the computer. So if you know the Taylor expansion of the natural algorithm, the Taylor expansion. The Taylor expansion, if you are using computer, so that will be displaying a finite precision truncated value. And that was actually happening over here. So it's actually a truncated value. It's not an exact value because this is E minus 1. So it's a truncated finite precision value. But if you are using the exact mathematics, and you're using some limits and some factorial things here, so this thing will actually go to 0. So this thing a n actually goes to 0. So instead of this many dollars or whatever my ridiculous amount in his bank, he actually got um, 0 or 0.33 in his account. 0.0.0339 in his account because the bank was using the exact mathematics. So computers have finite memory and finite precision. Petrarch missile example, no time for that, but it's a really important example. Reason is that if you look here, let me go here. It's an EPUB. I have uploaded this file. It's a really readable file. So this thing had the error of, I'm not so sure whether you can read it. I cannot zoom in here. I mean, the error was 0.000009. I mean, like it's really infinitesimal. I mean, really infinitely small error. But due to it, it was something like a half a second difference. It's a really telling story that the code was not upgraded and it was keeping track of time for a long amount of time, and all they needed to was to restart the system once a day, every day, so that the clock would reset and it will not have the compounding errors in which we had here. So it's a really telling example of the floating point arithmetic and how it messed up the old missile defenses. So coming to the actual code, where is that? So see you inshallah next Tuesday. See lecture 16, 17, 18. Any questions you want to write down in your chat window? So I will answer it over here. जिनको जाना है वो जाएं. Okay, Mudassir Mahmood. बाकी anybody, every student should hang up. If anybody wants to ask any questions, there are about 3 minutes remaining. I'm going to write the questions here. Beta, no audio. You have to write.
Sir, मेरा मैसेज नहीं जा रहा.
Said in float, double and long double, you said the self precision time, but output is just 247.19969 to 47.24. हाँ, set precision, ये बहुत अच्छा सवाल है मुदस्सिर महबूब, जज़ाकल्लाह. This thing 19999. Bhai, floating point has the smallest amount of float type, has the smallest amount of precision available. So it could not store 0.2 exactly. Okay. In the double and the long double, even though 0.2 is an infinity never-ending expression here, okay, but in double and long double, it actually was able to store point 2 almost. I'm not saying exactly, almost. So I mean the error was so small, or the difference between point 2 and 0.19999, a very long stream of number. So it actually was just displaying point 2. I'm not saying it could have been storing point 2 exactly, because it's not possible. Reason is that point 2 is a rational, repeating, never ending expression. So that's the problem here. But in double and in long double, the point 2 was stored almost as point 2. So that's why it was displaying that, okay, you to 47.2, that's okay. The error was actually so small that the it was I'm not exactly sure. You have to look at the normalized floating point numbers topic in some advanced book over there. But the gist of the matter is the error was extremely small, or should I say the quantization error here, or the quantization error was extremely small, that it would have not been possible for this double or long double to display e to the power minus 308 or 309 error. So that was actually some rounding off was actually happening in this point 2 of double and long double. So actually it's a long answer, but the error would have been so small. Beta attendance यहाँ लिखने की, do not need to write the attendance. I have taken the attendance. Nabil Majid sir, assignment कोई दिया है? No, अभी no assignment yet, but assignment and one quiz is going to come up. I'm going to announce it at least 1 week. For the quiz, I'm going to announce it 1 week before the actual quiz, obviously. And for assignment, you will be given, because we haven't done loops yet. For after we have done the loops, then we will be doing sorry, loops, and then what the next topic is, arrays. So after we have done loops and arrays, then you will be able to develop some real applications, because we are just for midterm, the topic is just if else statements. So and that's it. So some conditional statements and switch operator and conditional operator. Mid क्या लिखा है ये, mid Jan होगा, mid कब होगा? Mid की dates would be announced on the website. I think it's in the 8th or 9th week. We are in 5th week, right? I think we are in 5th week or 6th week. भाई पता नहीं यार, वो calendar, just see the calendar. Okay, that's it. Every student should hang up right now, and I will see you inshallah next week. Allah Hafiz.